Your height, the shape of your nose, your complexion, everything that makes you a unique individual are all passed down to you from your parents. These are all referred to as traits.
But what determines which traits will be passed down?
That was the same question asked by Austrian monk Gregor Mendel more than 100 years ago, and he decided to find the answer. Working with pea plants, Mendel learned several important rules about heredity. One was that an individual carried two factors, or genes, for each trait, but passed down only one. Another rule was that one of the factors, or genes, was dominant over the other.
Dominant?
That means it has more influence or power over the other. Let's use a simple example to explore these rules. If this black rabbit and white rabbit were to mate, what color do you suppose their offspring would be?
I don't know. Black? Maybe white? How about gray?
No need to guess. To find out, we'll use a simple diagram called a Punnett square. We'll assume there'll be 4 offspring, 1 for each square. 1, 2, 3, and 4. Next, we'll put the black rabbit here on the left and the white rabbit on top. According to the rules discovered by Mendel, we know that each rabbit carries 2 genes that control color. Let's say the black one is purebred for black.
Purebred?
That means both of its genes are black. We'll refer to them as capital F, capital F. F is for fur. The white rabbit is also purebred. That means that both of its genes are white. We'll refer to them as small f, small f.
Which genes will the offspring inherit?
Since the black rabbit carries only 2 black genes, capital F, it can only pass down a black gene to each one of the 4 offspring. Since the white rabbit carries only 2 white genes, small f, it can only pass down a white gene. Each of the 4 offspring end up with both a black gene and a white gene. But each will be black because black is dominant. They may look exactly like the black parent, but there is a big difference. These offspring are no longer purebred, but are now called hybrids. They carry both a white gene and a black gene. The black trait is dominant, and the white trait is recessive.
Recessive?
That means it's hidden.
Well, what would happen if 2 hybrid rabbits were to mate?
Let's do another diagram using a Punnett square. This offspring will receive a black gene from the parent on the left and a black gene from the parent on top. It will end up capital F, and will be purebred black. This offspring will get a black gene from the parent on the left and a white gene from the parent on top. It will end up capital F, but will be black because black is dominant. This offspring will end up with a white gene from the parent on the left and a black gene from the parent on top. It will end up small f, capital F, but will be black because, again, black is dominant. Finally, this offspring will end up with a white gene from the parent on the left and a white gene from the parent on top. What color will it be?
It has only white genes, so it has to be white.
Good. Now, which offspring gets which gene is completely up to chance. All we know for sure is that about 1 in 4 will be white. None of the rabbits will be gray, by the way, because in this example, these traits are not blended. The same rules of inheritance apply to many of the traits found in all plants and animals. If you were to cross hybrid purple corn with hybrid yellow corn, what would be the result?
That would depend on which color is dominant.
Right. And since purple is dominant, the ears would have kernels that are about 75% purple and 25% yellow. 3 to 1.